Hurricane season is here, so the big question is, what is in store for the upcoming 2019 season? So as you've probably heard, we've already had two hurricanes. The first one was Alvin, and the second one was Barbara. What will be the upcoming ones, and what will they have in store for us? This year is projected to have a 40% chance of being a near-normal season and a 30% chance of being above normal, according to the National Oceanic and Atmospheric Administration Climate Prediction Center's 2019 hurricane forecast. An average hurricane season produces 12 named storms of winds of 39 miles per hour or higher, including 6 hurricanes and 3 major hurricanes of Category 3, 4, or 5. For 2019, the NOAA forecast calls for 9 to 15 named storms, including 4 to 8 hurricanes and 2 to 4 major hurricanes, quoted from usgs.gov. Before a storm's expected landfall, coastal change experts forecast how a storm may reshape the coastline using a sophisticated system they developed called the Coastal Change Hazard Forecast Mode. The model provides detailed forecasts of a strong storm's likely effects on sandy shorelines along the Atlantic and Gulf coasts. It predicts where protective sand dunes are likely to be eroded at their bases or overtopped by storm waves, and where coastal areas beyond the dunes could be affected by seawater. Knowing this information would allow emergency managers and local governments to issue evacuation orders and/or prepare their people of what is to come with the storm. Making sure you know your evacuation route is crucial for getting away from an approaching storm in a safe and timely manner. Working with the National Weather Service, the Coastal Hazard Storm Team also updates forecasts for what some areas could be affected by several times a day using real-time water levels from the National Weather Service's near-shore wave prediction system. The team's total water level and coastal change forecast viewer displays results from a new model that currently covers about 1,865 miles of coastline in select areas from Florida through Maine. This year, NOAA will use the predictions to help inform forecasters at the National Hurricane Center. As the program's coverage area expands, the predictions will also be made more available and reachable to the National Weather Service forecasting offices and even to the public, helping people plan ahead. NASA's role as a research agency is to bring new types of observational capabilities and analytical tools to learn about the fundamental processes that drive hurricanes, and work to incorporate the data into forecasts which meteorologists can use. NASA collaborates with its partners so that the nation benefits from our respective capabilities. Quote from NASA. Another quote from NASA is, NASA uses an arsenal of instruments to learn more about how these storms progress as they form. These devices orbit Earth on a fleet of spacecraft, including Aqua, Terra, and Global Precipitation Measurement Corps Observatory, NASA/NOAA's SOMI, NPP satellite, Calypso, Jason-2, and CloudSat also benefit from learning new information and help the public be informed. And that's also a quote from NASA. These instruments analyze different aspects of these storms, such as rainfall rates, surface wind speed, cloud heights, ocean heat, environmental temperature, and also including humidity. Observing these factors helps identify any part of the storm in strengthening. Similarly, the data allows meteorologists to better predict where and how hard hurricanes will hit. Looking at cloud structure also helps us understand the storm structure, which improves our forecast, says Michael Brennan, a senior hurricane specialist at NOAA Hurricane Center. Having satellites to watch oceans is crucial, and that will never change. Radars on Earth can only see a certain distance out into the ocean. So with spacecraft, you'd be able to see everything. And without spacecraft, you would have to have radars in every single ship. That's a quote from NASA. And just think about that for a minute. If you didn't have a radar on every ship, you would only have limited coverage, and it wouldn't be reliable. So the fact that we are getting things in this space, and that we are working to get better technology and communications up there, is really crucial to how we live today. I mean, think about Google Maps and everything. They use satellites. Even the radar on your phone is satellites, and it works with Doppler systems. And it's not saying that the Doppler systems on the ground are bad, it's just that they're limited. They're really good at close range on the ground, but they can't cover everything. So when it comes to hurricanes out over the ocean, we don't really have too many Dopplers out there. So this is where the spacecraft comes in, and this is how NASA helps meteorology. NASA's global modeling System, or GMAO, works to improve understanding hurricanes and assesses modes in all procedures to improve the quality of information and communications. GMAO helps identify information that was missing and determines what services could be added to help future investigation and prediction of hurricane systems. NASA also conducts field missions to study hurricanes with an arsenal of instruments ranging from radiometers that read moisture levels, lidars that measure aerosols, moisture, and winds. Sorry if I said that wrong. It just looks weird whenever you have the quote here. The Dropson systems to measure high-resolution profiles of temperature, pressure, moisture, and winds, and even Doppler systems that map 3D precipitation and winds within the storms. These instruments monitor the structure and environment of hurricanes and tropical storms as they evolve. The 3D structures even can compile stuff to the tornadoes and everything. That's where they were originally tested, because whenever you can 3D model a tornado, you can see how it's building, and when you take that to a massive scale of like a hurricane, that'll let you see where that core is at and everything, and allow you to really get a perfect view of what the hurricane looks like. In the most recent NASA field mission to study hurricanes was Severe Storm Sentinel, or HS-3. For 3 consecutive years, the HS-3 mission investigated the processes that underlie hurricane formation and intensity change in the Atlantic Ocean basin. The mission used the Global Hawk, a high-altitude long-endurance aircraft capable of flights of 26 hours at altitudes above 55,000 feet. Flying at the Wallops Flight Facility in Virginia, the uninhabited Global Hawks could cover the entire Atlantic Ocean, enabling measurements of storms at early stages in every stage, from the central or eastern Atlantic, or spending 12 to 18 hours over storms in the western Atlantic. So these spacecraft and planes pretty much can actually cover these expanses of ranges, and even if there's 2 hurricanes at the exact same time, it could cover those. I mean, that doesn't happen all that much, but it could. So I mean, flying at 55,000 feet for 26 hours, imagine the amount of useful information you are just getting from one flight. NASA data and research allow scientists to observe the fundamental processes that drive hurricanes. Meteorologists incorporate this satellite, aircraft, and computer modeling data in the forecast for the United States and all around the world. Max Gleiber of NASA's Goddard Space Flight Center quotes that, and there were multiple other quotes that when you look, NASA is a major part of how the National Weather Service and NOAA works. Since they all integrate together, they can share information, and it's really handy that we can combine multiple resources so we can get the best accurate data possible. There's a lot more behind your basic forecast than what you think. So here comes a lot of information at once. There is a chart currently, since you're listening to the podcast version of this. I don't have the video one up yet. It's going to be a little bit weird. I'm not going to say all the data on here, but just giving some generalizations over what the total and average number of tropical hurricanes by month have been from 1851 through 2017. Got this off of a website called hurricanesandData.com. So looking at this, January through April, there's nothing there. There's less than 0.05, my bad, averaging per month on tropical storms, hurricanes, and there are no landfalling hurricanes in the U.S. But when you get to May, you have some that kick up. There have been 4 hurricanes since 1851 in May, and there have been 22 tropical storms. Then you get into the summer, you look at June and July, there's 92 to 120 tropical storms, and there's been 33 to 55 hurricanes, 19 landfalling, 25 landfalling in June and July. But hurricane season goes from June until pretty much the end of October, beginning of November. So when you look at it, everyone always says, yeah, September is a big time. Well, when you look at it, it is. It's the peak time of the year for hurricanes. But let's look at August and September here for a second, because August is where it really starts to ramp up. So since 1851, there have been 389 tropical storms to come to the U.S. in August. In September, there have been 584. So, I mean, you're looking at almost 200 of a difference over 1 month there in the past, what's it been, almost 200 years? So, ever since I started recording. So, 150 years, I mean, you get around 900 and some hurricanes between August and September. My bad, not hurricanes, tropical storms. So when you look, September averages 3.5 tropical storms since then. So in the year, that adds up to 9.9 when you look at the other months combined. But no other month has 3. I mean, August has 2.3, but they average 3.5 in September. And then you look at hurricanes, and let's transfer over to that. August has 245, and September has 404 actual hurricanes. So there's a big difference there. And then let's look at the landfalling hurricanes. There's been 111 in September in the past years. There's been 80 in August. So that's not meaning every year. You have to remember that. This is combined. So when you look at the actual average, the averages are all weird because you look for tropical storms, August has 2.3. For hurricanes, August has 1.5. For landfalling hurricanes, it's 0.48 since 1851. September has 3.5 tropical storms per month, or per year, I guess, technically, since we're just taking it down to September, and then 2.4 hurricanes, and then there have been 0.67 hurricanes. So you have to remember, too, since this is such a big spanned out time and drawn out, you have to keep in mind that there are a lot of years in there where there haven't been that many hurricanes. So that's why that number goes below 1, is because some years don't, some years do have a lot. And so more than others can compensate for the amount of time and the amount of hurricanes that we have. And there's not really much information about how strong some of them are because radar data and actual investigative data has changed. Considering it started in 1851, technology wasn't that huge back then. TVs and everything, that wasn't even around. Or if you're thinking about, they had ways of tracking it down with paper and everything. Well, still, that was rare. You only had that in a few circumstances. So getting key, accurate data is harder to tell. And there was not really a system of separating tropical storms from hurricanes. You could tell because one was much more destructive. But if you look at the scale, it's completely changed since then. And so basically summing up the data off the chart here, so since 1851, the data shows us, on average, tropical storms are most prevalent from August into September. General hurricanes occur the most in September, and U.S. landfalling hurricanes have a massive increase during the middle of September. Early September have some, and the end of September have some, but those middle 2 weeks of September are when the most landfalling U.S. landfalling hurricanes occur. And so pretty much to sum this all up, it's crazy how many hurricanes we actually have. Looking since 1851, there have been 1,600 tropical storms, about 1,000 hurricanes, and almost 300 landfalling hurricanes. So that's a lot. And when you look at it, it's easy for them to occur. And with climate change and everything, it'll be interesting to see where that is in the upcoming years. So I just wanted to get another episode out here, and this one was talking about hurricanes, since we're here and we're already going to our third name hurricane here coming up, and a bunch of the invests are starting to be formed over the Atlantic, and so since all that's happening, I wanted to get this episode out, and so yeah, thank you for listening, and make sure to check out our social media. Links are going to be in the descriptions, and watch our video version of the show whenever that comes out. Check out the social media. Twitter will have it posted first, and then Instagram will have some photos posted from it. But we are making some changes here coming up, so stay tuned for those. And check out some of our next episodes coming out. One's going to be how Alaska actually gets warmer than some U.S. states that are in the continental U.S. It's crazy how hot it gets there, and they just broke a record recently. I think it was 90 is the first time that they've ever hit that recorded record. So it's crazy. So we'll see where that's going to go, and stay tuned, and hope you all have a great day. Thank you very much for listening.